Today I have planned to create some short videos for my DP students for quick revision of the unit wave phenomena. And the first topic in the wave phenomena is simple harmonic motion. Now, when we talk about the simple harmonic motion, so the first question comes in our mind is, what is simple harmonic motion? We can take the example of simple pendulum here. If I give a small displacement to this simple pendulum, it will go back and forth about the equilibrium position. This is the equilibrium position. I can write a point M which represents the equilibrium position. Now the pendulum is displaced towards the right side by a displacement of x, and when it will come back to its mean position, it will go same distance towards the right side as well. So this displacement x is from the equilibrium position, and it's equal both the side if there is no other external force acting on the simple pendulum. Pendulum comes back to its mean position and shoots back towards the other side, and again comes back to its mean position because of the restoring force. And when there is force, we know that there must be acceleration. So acceleration in case of SHMA is directly proportional to the displacement. Now, if you will see any simulation, you will find that the displacement is towards the right side, then the acceleration will be towards the left side. And if displacement is towards the left side, acceleration would be towards the right side. So we can say that the acceleration and displacement, they both are opposite, and I need to add a negative sign here. So this relation is for simple harmonic motion. I can write it in the form of equation, and it can be written as A is equal to minus omega square x. And omega here, omega is represents the angular frequency. And omega is written as omega is equal to 2 pi by t. In case of simple pendulum, if we want to find the time period of simple pendulum, we can write t is equal to 2 pi under root L by G. And if there is a spring mass system, then we can find time period t by using t is equal to 2 pi under root the mass of the block which is attached with the spring and which is in oscillation, divided by the restoring constant of the spring.